where we ended on the nephron, then the functions of the nephron. Today we are going to take, or we are going to look at the juxtaglomerular apparatus. Now, when we say juxtaglomerular apparatus, what does it mean? The juxtaglomerular apparatus, we are talking about a region in each nephron where the afferent arteriole and the distal convoluted tubule, where they come into contact, is what is called the juxtaglomerular apparatus. Where the afferent arteriole and the distal convoluted tubule comes into contact, is called the juxtaglomerular apparatus. Remember that the afferent arteriole is made up of cells. The distal convoluted tubule is also made up of cells. The afferent arteriole is made up of granular cells, and the distal convoluted tubule is also made up of macular denser cells. So as they meet at this point, their cells becomes modified. As they meet at this point, the cells becomes what? Modified at the point of what? Contact. And as you all know, the modified cells, that is what makes up the juxtaglomerular apparatus. And again, the function of the juxtaglomerular apparatus is to help to regulate renal blood pressure. The function of the juxtaglomerular apparatus is to regulate renal blood pressure. Now, what is the function of the granular cells of the afferent arteriole? Now, one of the functions of the granular cells of the afferent arteriole is to secrete enzyme called renin. And the renin is RGNIN. Now, when the renin is produced, it is released into the blood. Now, as the renin gets into the blood, the renin converts a plasma protein called angiotensinogen into angiotensin 1. Then there is an enzyme from the vessels of the lungs called angiotensin converting enzyme. Now, this angiotensin converting enzyme will convert the angiotensin 1 to angiotensin 2. So the angiotensin 2 will move to where the kidney is, go and trigger the adrenal cortex of the adrenal gland to cause the secretion of aldosterone. So the aldosterone will help to cause salt and water to be retained by the kidneys. And remember that this process I was explaining is a mechanism that is called renin angiotensin aldosterone mechanism or aldosterone system. Now, how does this process come in? This process only comes in when there is what? Decrease in your blood volume. Whenever there is decrease in your blood volume, this process is what? Triggered in order to cause increased salt and water retention. But in a nutshell, whenever there is increase in your blood volume, this process is inhibited so that more urine can be what? Brought out to decrease your blood volume. Now, what are some of the processes that leads to urine formation? Now, urine formation has three phases, or it has three processes, namely filtration, selective reabsorption, and tubular secretion or excretion. Now, let's take the filtration. As we all know the function of the glomerulus, the average blood supply to the kidney, every day, if the kidney supplies 100% of blood to the whole part of the body, about 21% of that blood goes to the kidney each minute. So in each minute, the 100% of blood that is formed by the heart, 21% of the 100% goes to the what? The kidneys for its activity. Among the 21% of the blood that goes to the kidney, about 90% of the 21% of the blood plasma that flows through the glomerular capillaries passes through the filtrate membrane into the Bowman capsule. So assuming 21% of blood entered into the afferent arteriole. Now as it entered, about 90% of them will pass through the filtrate membrane to come here into the Bowman capsule as what? Glomerular filtrate. And again, in both of the kidneys, we have about 180 liters of filtrates that are produced each day. Both kidneys are able to produce 180 liters of filtrates each day. And among the 180 liters that are produced each day, 1% or less will become urine. So it means that not all the filtrates that will come into the Bowman capsule will be formed as what? Urine. About 1% or less will become what? Urine. And again, what is filtration? Filtration occurs whenever there is movement of material across a filtration membrane into the lumen of the Bowman capsule. Whenever blood enters into the afferent arteriole and some of the blood are filtered through the pores or the filtration membrane into the Bowman capsule, then filtration has what? Occurred. Now, some book of thought also describe filtration or glomerular filtration as the process that forces some of the water and dissolves substances of the blood plasma from the glomerulus. The forces that force or that pushes dissolved substances and water from the glomerulus into the Bowman's capsule or into the glomerular capsule due to hydrostatic pressure within the glomerulus. Within the glomerulus, there is a pressure, and I told them the normal glomerular or hydrostatic pressure within the glomerulus is 55 millimeters of what? Mercury. And it is that pressure that pushes the dissolved substances into the Bowman capsule to become what? Glomerular filtrates. Now, during filtration, there are certain factors that are responsible for filtration to occur. What are they? There are two main factors. The first factor is permeability of the glomerular capillary wall. Now, this is our capillary wall. Assuming this capillary wall is sealed, the pores are sealed, filtration will not occur. But because they are permeable, filtration will occur. The second factor is blood pressure within the glomerulus. And we know that the glomerulus carries hydrostatic pressure of 55 millimeters of what? Mercury. And for that matter, it will enhance or it will force some dissolved substances to come out of the filtrate membrane into the Bowman's capsule. Now, note that the glomerular capillaries, they are much permeable to substances that are in the blood than the other capillaries. Glomerular capillaries, they are permeable to substances that are in the blood than the other capillaries. Why? It is so because the walls of those capillaries or glomerulus, they are made up of numerous pores. So the numerous pores makes it what? Porous. And it's because of the pores. It allows water and most dissolved substances that are in the blood to easily pass through the capillary walls into the glomerular capsule or Bowman's capsule. But the pores, as we said, it is in nanometer. The size of the pore is in nanometer. So they are too small to prevent plasma protein like albumin, globulin, then blood cells from entering into the what? The Bowman's capsule. So in a nutshell, protein, blood cells should not come into the Bowman's capsule. Now, why is it that we have higher glomerular blood pressure? There is higher glomerular blood pressure because the diameter of the efferent arteriole is smaller than the diameter of the what? Afferent arteriole. Look at it. By this one. It is not as it is. But the diameter of the afferent is larger than the diameter of the what? Efferent. That is why there is glomerular pressure to be higher within the glomerulus. Now, the reason why there is higher pressure within the glomerulus is also that blood enters into the afferent faster. But when the blood wants to leave, there is pressure because the diameter is smaller. So there is always build-up of what? Pressure within the glomerulus. And it is the glomerular blood pressure that provides force for filtration. Any question? Now, let's look at the factors that also determines filtration pressure. Now, one of the factors that determines filtration pressure is pressure difference between glomerular capillaries. Now, when it happens that the pressure within the glomerular capillaries is negative, it will affect the filtration. When it happens that it is the normal pressure within the capillaries, it will also affect it, either positive or what? Negative. Then the second factor is the blood pressure in the glomerular capsule. Now, we are saying we have pressure within the glomerulus. We also have pressure within the Bowman's capsule. Because it is the pressure within the Bowman capsule that will push the filtrate into the proximal convoluted tube. Then the last one is the protein or blood protein concentration. Now, wherever protein is located, there is increased osmotic pressure, and that will also influence what? Filtration. But remember that whenever fluid from the glomerulus enters into the glomerular capsule or the Bowman capsule, it is known as what? Glomerular filtrates. And the glomerular filtrates consists of substances that are found in the blood, apart from blood cells and what? Protein. So the glomerular filtrate is similar to blood, but the difference is that the glomerular filtrate do not contain blood cell and protein, but blood is made up of protein and blood cell. So we will end this lectures here. Then we'll continue with the glomerular filtration rates some other time.